Now in neural network, we're going to continue to introduce the activation function and when you're supposed to use them. For this one, I'm going to talk about sigmoid and Tanh. This one is going to be sigmoid. For sigmoid, I will put 0 here so we can see what's happening. And this is 1. Okay, and then for this one, I just have 0. So for this one, for example, when you are close to 0.5, you're almost 0. So it is not reaching exactly 0, and then it will look something like this. So in this plot, if you get any value close to 0, you're gonna be on this area of your activation function. And the good thing about this is because it is more steep, so the steeper that you are, more learning is going to happen. This is very important in choosing your activation function. I'll show you why. So right now, based on this, I'm saying that wherever I am very steep, that means that my learning is higher. The places that you're more like a line, it's more like a straight line, the learning is going to be very slow and small because the gradient is going to be small. So based on that description, the gradient for sigmoid is going to look something like this. So we have lower values here, and then when you're going toward the steepness, you are getting to the maximum, and then again at the end you're going back down to the minimum. So the parts that were very steep, you're gonna have higher gradient, which means the learning happens the most in that area. I'm gonna plot Tanh right now too, so we see how it looks like, and then we're gonna talk about it. Again for Tanh, okay, so there is a difference here. Right now in sigmoid, whatever value you're getting, you can only output between 0 and 1, and you can't even do 0 or 1. You're just getting close to 0 and 1. Okay, and so keep that in mind. And then we're gonna look at Tanh. Tanh is going to be able to give you both positive and negative. So sigmoid is between 0 and 1. The output is going to be between 0 and 1. And then for Tanh, I put the 0 in the middle here, and then I just go all the way here, -1, and I go here 1, okay? And then we have 0 here, -1, -2, 1, 2, 3. Okay, so now when we're talking about Tanh, you're going to have the same shape, but it is between -1 and 1. Now, if you want to draw the gradient, it's again going to be very similar to the gradient of sigmoid. It is a little bit more intense. So when you're getting here, so you will have a shape like this. So now let's talk about what they can do and where you should use them. Okay, let's first go with sigmoid. Sigmoid, as you can see, we start from somewhere around 0 to 1, right? So any output that comes from a neuron that has activation function of sigmoid, it can only produce values between 0 and 1, and not exactly 0 and 1. It's going to travel close to 0 and 1. What that gives you is a probability. So if you want to do classification, you cannot use step function because step function cannot learn, and I tell you why. Mathematically, step function is not capable of learning, okay? Because of this, because when we're talking about learning, we are talking about the gradient. Gradients are very important. Gradients either in activation function or in loss function. If I have a step function, like I have 0 here and I have 1, and then my step function looks like this, okay? So this is a step function. Instead of using sigmoid, I'm just going to use a step function. Why not? If you want to do binary yes or no, you can just do actual yes or no, and you can actually get 0 and 1. But this cannot learn. The reason is gradient would work with steepness. So when you have a vertical line here, the gradient for this or derivative for this is not defined, okay? So when the gradient is not defined, it doesn't know how to learn here. And then again, you go to this area and it's all flat. So the gradient or the derivative is 0. The gradient or derivative for this is 0. So learning is not happening. So you cannot use a step function for a complicated neural network, and even if you just want to get the binary values of zeros and 1. But you can use sigmoid. It is still completely acceptable to use sigmoid in your output layer. Even though it's never going to reach 0 or 1, it will give you a probability. Okay, so it will tell you, so there's a 70% chance that my answer is yes, and 30% chance that my answer is no. Okay, so it's true that you're not getting a solid yes or no, but you have probability, which makes it even better, because then you can set the threshold on different levels. For this one, you cannot set a threshold, but for this one, I can say, okay, so my cutoff is going to be at 80%. So anything below 80%, just say no. Anything above 80%, say yes. So we said sigmoid is okay for using it in the output layer, and as the shape shows, you're using it for binary classification mainly. But why can't we use it in hidden layers? What is the problem that we can't use it in hidden layers? There are a couple of problems. When you hear people say Tanh is the improvement of sigmoid, it is and it is not. It is not, because Tanh is not used in the output for binary classification, which sigmoid is used for. Sigmoid is used for the binary classification in the output layer. So Tanh is not exactly an improvement of sigmoid, but in some cases it had improved its ability. But if we are talking about using activation function in hidden layer, Tanh would do better than sigmoid because of multiple reasons. One, sigmoid doesn't have real 0. As we said, it's going to travel towards 0, but it does not have 0. So no 0. And why is that a problem? When you are going through hidden layers of neural network, some of the neurons are going to be turned off because they output 0. And that would help learning happen, because you don't care about the information that is coming from the neuron that's already off. Okay, so having 0 in your hidden layers are important because you can reduce the number of features, reduce the number of neurons that are sending signal to the next neuron. So you're basically simplifying what is happening. So getting a 0 is important, and sigmoid is not capable of getting 0. Sigmoid is not able to output 0. So it doesn't matter how irrelevant that feature or that neuron is, it will still send some small signals. It is still not off, okay? So sigmoid cannot turn neurons off. That is one of the reasons that you don't want to use it in hidden layer. It's going to cause problems. So if you have a very deep neural network and you're using sigmoid in your hidden layer, you're going to have vanishing gradient problem, which means that it will reduce the importance of the features that are further away from it. And the activation function gradient is supposed to work in favor of your data, and that's why it is important to choose your activation function correctly. So now the third reason that sigmoid is not good for hidden layer is because no negative. You cannot output any negative number. Anything that you give in, you will get a value between 0 and 1 out, okay? So no negative number. But then you might ask, well, why does that matter? If I want to reach this green point here, in the middle here, okay? And I am starting from here. Sigmoid tells me you're far away, go forward. I go forward. And then again, I stop here. And sigmoid tells me you're far away, go forward. I go forward. I stop here. And then sigmoid again tells me you're far away. So I go forward and I'm here, okay? So I was there and I was going forward and it was fine because I was going toward the place that I had to be. But now I have passed this point because my step was bigger than the last point, right? So now sigmoid again tells me you're not there, go forward, because it doesn't have a negative number. So now, even though my relationship with that point had changed, so that means that I need to decrease instead of increase, since I don't have negative, since sigmoid cannot give me negative number, it just says that you're not there. So it's going to be more complicated for me to figure out what I have to do, because if I had like positive and negative direction, then you would say, well, yeah, you are far, but you have to go, like you have to decrease instead of increasing. Okay, so now we talked about sigmoid. Now this part is very interesting. You probably heard that whenever you're using Tanh, you're supposed to use, it's better, not supposed to, but I mean, you're supposed to kind of, you're supposed to use a zero-centered data. So why is that important? If you look at the gradient of Tanh, you will see that around 0, you have the highest amount of learning. So that means there's a lot of learning happening around 0 and any value close to 0. And then again, you spread out when you're going further away. Again, you're gonna have the vanishing problem because it's gonna get saturated, it's gonna get way smaller values. So you see that this have to be more centered, but all of these things are happening around 0, right? So you have the most amount of learning happening around the values close to 0. So when you take what you do when you center your data close to 0, you get the mean, the average, and then you keep the average as 0, and then all of the other values are going to be around your mean. So that means you're getting, if your data doesn't have outliers, that means that you gathered most of your data around the 0, which is mean, around the center. So when most of your data is around the center, that is where the most amount of learning happens. That is why Tanh works. That is why Tanh works well with centered data, zero-centered data. Because we are getting the mean, we take the mean as 0, and we spread all of the other data around it, okay? If you don't have outliers, there's a very good chance that most of your data are closer to your 0. And if your data is closer to your 0, you are exactly in the position that most amount of learning happens in Tanh. So Tanh is going to be very useful. But again, as you can see, so your data have to be all centered around 0, so you will do best, right? So what's going to happen if you are centering your data but you have lots of outliers? Those outliers are going to really affect you, because you're centering 0 and then most of your data are outliers, so your data are going to be further away. So that means your training is going to be slower. In those type of cases, you probably want to use ReLU or leaky ReLU.